Okay, so let's take a try on example 2. In example 2, we're given two problems. One is just factoring, the other one is solving. So the directions for both of them are a bit different, even though they have some similarities that we're going to talk about momentarily. Sometimes we can factor out monomial or otherwise common terms in a polynomial to make things a little bit easier for us. So if we look at example 2, letter C, we notice that there's an x that is part of each of those three terms. So before we start factoring, it helps us, and it's actually easier if we can take out that common factor first before we go about and we start factoring the bigger group. So since all three terms have x in common, I'm going to pull that x out, which means I have two x's, or x squared I should say, left over as my first term inside that grouping. I have one x left over from the middle term, and when I pull the x out, I have a plus 6 left over from that last term. At this point, I can take this large group and I can go ahead and factor and try to break that down. And from our practicing of our factors that we've been practicing all along, a lot of you can recognize the steps involved for breaking this down a little bit further. So this guy right here can actually break down into two smaller groups. We need a number or two numbers that multiply to give me 6 and that add and subtract to give me 5. So that can be a couple different things. That can be 6 and 1, and that can also be 2 and 3. But we also need a -5 out of the deal. So if we break this down, the 1 and 6 can't really give me a -5 unless I have one of them that's negative and one of them that's positive. But I need a +6 when I multiply. So to get that, I need both of my terms to be negative. So the -3 and -2 give me a +6. And when I add them, I get -3 plus -2, that gives me the -5. So letter C should be factored as three separate groups: x, x minus 3, and x minus 2. In letter D, similarly to letter C, we're going to factor this as well. The difference is they're asking us to solve for letter D, and solving just means at the very end when we factor all of our groups down, we want to set each of those groups equal to 0 to find out what those x-intercepts or x values are. Again, if we just look on the left-hand side, since it's already being set equal to 0, is there a value or values that I can pull out of both of those terms? And if we look at it closely, we notice that we can actually pull a 2x out. So when I pull a 2x out, I have 8x cubed left over from my first term, minus, and I pulled the whole 2x out here, so I need a placeholder now since there's no longer the 2 and the x, and I get the 1 equals 0. At this point, we have to ask ourselves if we can break this down any further. And our outside terms, because we pulled that out, generally those are already going to be simplified. So inside our parentheses, the 8x cubed minus 1, we notice that all of those terms can be broken down into perfect cubes. And this is what we did in example 1. So the first thing I'm going to do is off to the right, I'm just going to break down the 8x cubed minus 1 all into perfect cubes. So if I do that, 8 before it was cubed was 2 cubed. X before it was cubed was obviously x cubed minus 1 cubed. Go ahead and circle out all of those values. Same thing here, I can't forget about my 2x. But I now know I can factor this guy down into dash dash, dash dash dash. I can break him down. My first group, my first two dashes is going to be what I circled out from above, 2x minus 1. Inside my next parentheses, my first value here is going to be my first term squared, both terms being squared, so I get 2 squared, which is 4, x squared, which is x squared. My middle term is the two of these multiplied together. 2x times the 1 gives me 2x. And my last term, which is the 1 squared, is going to give me 1. Started off negative. This guy over here gives me a positive, right, because they're opposite. And my last term is always positive. At this point, we want to see if we can factor this quadratic down any further. We know we can't pull anything out of this guy anymore, then it's already been simplified, so he stays his own group. We want to see if we can break this guy down any further. And we do that by seeing if we can factor it the old school way, and that's just by seeing if there's values here that can 4 and 1 or 2 and 2. Here we only have the options of 1 and 1, seeing if we can break it down the same way that we broke down our values over here. I'm just going to save you a little bit of time and tell you that it won't work out as nicely as letter C will. So when we're in a situation where we're getting stuck and we can't break it down into nice groups, I know you guys have all heard of this before, we're going to use the quadratic formula. I think you guys remember that as being the negative b plus or minus square root of b squared minus 4ac all over 2 times a. The 4 in this case would be our a, the 2 in this case would be our b, and the 1 in this case would be our c. If we plug those values in and we crunch them, we would be able to break down and find out what x was going to be equal to. In this particular case, if we plug in 4, 2, and 1 into our a, b, and c and we crunch these numbers, what you're going to notice is this group right here gives us an imaginary number, or 2 imaginary numbers. So they're not real. So in this case, our imaginary numbers, we're going to solve. Sometimes if we're solving for all x values, we're going to include our imaginary numbers. If it says solve for all real solutions, then the fact that it's imaginary is going to take this group out of the running, and we won't include these x values at all. Graphically, what that means is these 2 x values that would come from this group, if we break it down, are not going to be solutions or x-intercepts on our graph, and we'll talk about that a little bit later. So for the time being, we're just going to notice that this is imaginary numbers. We're going to exclude this value from our answer set, and now we're just looking at 2 groups that we're setting equal to 0. So if we take 2x, set it equal to 0, and solve for x, divide both sides by 2, so x is going to equal 0. That's going to be one answer, one real solution. The other one is if we take 2x minus 1 and set it equal to 0. If I minus the 1 and divide by 2, I should get x is equal to 1/2. Again, we've got 2 solid real x solutions here. The other 2 that we would have gotten are imaginary numbers, so we're just going to exclude them for right now. I will talk a little bit more about that the next time we meet in class, because sometimes those x values are going to be important. So we're going to want all solutions to be included. If the directions say to solve for the real solutions, then the real solution values that we get would be the only ones to include. So for right now, we're going to exclude the 2 imaginary numbers that we get from this in the quadratic formula. We'll just leave these 2 as our real solutions for letter D. At this point, you can go ahead and see if you can break down numbers 5 through 8 in the Now You Tries, and we'll check those answers tomorrow in class.